What I've found in the various times that I've taught this course is that most students are fairly familiar with what complex numbers are and with the notion that I is the square root of -1. Um, but when I ask if anyone's ever heard of the complex plane, that's where everybody says, no, I've never heard of that. So let me explain what that is. The What I've put on the left is the Cartesian plane. We all understand that given a pair of numbers we call x and y, we can treat those numbers as corresponding to a point in the Cartesian plane. So if I give you the pair of numbers 4 comma 3, then we all understand that what you do is you walk 4 steps to the right and 3 steps up and you get to the location of that point. So notice that a complex number z equals a plus bi is also kind of a pair of real numbers. So for example, let's suppose that I make this a specific number like 4 plus 3i. Let's suppose that I relabel the axes. So instead of calling the horizontal axis the x-axis, I call it the real axis. And instead of calling the vertical axis the y-axis, I call it the imaginary axis. So now it makes sense to say that this complex number z actually lives somewhere on the plane. That we treat the horizontal as representing the real part, we treat the vertical as representing the imaginary part, and we can plot the number 4 plus 3i as being right here on the plane. So that's 4 plus 3i. The same as the point 43 lives in the equivalent spot on the Cartesian plane. It's the same plane, it's just a different interpretation of the plane. So we can do this, of course, with any other number. Like, for example, I'm just going to put here that the number, let's put up a couple of other numbers. So let's say that, let's call that z1, and let's say that z2 is equal to just I itself, which we know is 0 plus 1i. Well, we can easily see that that's just going to correspond to where the point 0, 1 would go. So this is the number I. And I can also, let's see, let's pick another number, z3. Let's call it like -2i. And we can see that that's just going to go at the point, that's going to go where 0, -2 would go, because this is going to be 0 plus -2i. So that point will go right there. This is going to be -2i. And do another one. We'll do like, say, z4 equals -1 minus I. So here we have the real part is -1. The imaginary part is also -1. And we see that we have, that's the number -1 minus I. Okay, so the point is, of course, that every complex number can be plotted someplace on the plane, just the same as how every real number can be plotted on a number line. So we'll go on from that, and I'll show you where we're going with this.